Your first project in this class is going to be designing a fictitious NASA mission patch for an upcoming mission. So I've got a slideshow here that's going to talk to you about mission patches over the years. So this was the very first one that was used. It's you can see it's kind of rough looking. Mission patches have been worn by NASA astronauts since 1965, and so this is an image of a guy up in space, and he's got a bunch of these NASA the mission patches. Each mission that goes up has its own patch that's designed, and they usually have the astronauts' last names on them. So what they do with them is they send a whole bunch of them up in space, and then when they come back, they give them out to dignitaries and stuff like that, because I guess things that go up into space are valuable. So each mission patch is unique. They come in many different shapes. Many patches use a traditional red and white theme, while others take a more colorful approach. This is just some of the patches over the years. And I'm gonna give you a website at some point where you can go and you can look at all of the patches. So I've got a lot of different ones I'm going to show you here. I've got the years up in the upper left-hand corner so you can see what they, how they've developed, and I've got some details to tell you about them. So mission patches are personal to the specific crew. They're worn on their suits during the mission and at various events before and after the mission, and they almost always contain the astronauts' names. This is from 1969. This is the Apollo 11 mission. So this is the infamous one that landed on the moon for the first time. It does not have the astronauts' names on this patch because this was famously for all mankind. Everybody at NASA was behind the mission. It shows the eagle with olive leaves symbolizing the bringing of peace to the moon. Earth can be seen in the background. And so you'll remember that one of his famous words was, "The eagle has landed," when the spaceship finally touched down. And so what I've got here is on the left is the design as it was designed on the computer or by hand in the old days, and on the right I've got what the actual patch looks like once it's stitched. So you can see there's a lot more details over in the left hand side when it's designed, which is the step you're going to be doing, and then when it gets patched, they've got to get rid of some of the details. Apollo 13. So Houston, we have a problem. The lunar landing was aborted after an oxygen tank in the service module failed 2 days into the mission. So there were 3 astronauts. So we've got the 3 horses here. And if you look really closely, I'm not sure if you can see it here, but right here where I'm circling, it has the initials NT. Which was the guy that did the artwork. Norman Tiller was the one that designed this. So if you haven't watched the movie Apollo 13, I strongly recommend it, starring Tom Hanks and Kevin Bacon and other wonderful people, Gary Sinise. Before the use of computer illustration software, patch designs were airbrushed. The airbrushed originals averaged about 30 inches in size. So this is an example of one before they did it on the computers. I think 1984 was the first year that the Mac computers came out, I think. Might be wrong on that. 85. Crew members have always given input into the design of the patch for their missions. Initially, all crew members would meet with the designer. There could be 5 or 6 crew members, all giving conflicting opinions. Over time, that was simplified to one crew member delaying the ideas. This is usually the commander of the mission. So I listened to a podcast years ago by one of the main designers of these patches over the years, and he said that before they made this rule about only one of them talking to the designer, he would have the different astronauts. You can see on this mission, there were 5 different, 5 different people coming in, popping into the office. Hey, let's try this. Let's change this color. Let's do this. And it would take forever. And he finally put his foot down and he said, look, I can't have everybody coming in here. Let's get the commander. You guys talk to the commander. The commander will bring me the information and I will work on it from there. But the astronauts have a lot of input into the design of the missions. This is the first patch designed by a woman named Jennifer, Hees, Hees. Unfortunately, it turned out to be the patch for the Space Shuttle accident, the Space Shuttle Challenger, during its 10th launch because it was the Challenger that was used over and over again. In 1986, it exploded 73 seconds after liftoff, killing all of the 7 crew members. In 1985, so the year before, they had a contest. I guess there were so many missions, it had become so common for the space shuttle to be taking off and returning. They had made this space shuttle so that the rocket could go up, and then instead of splashing down into the ocean and not being able to be used again, they made this space shuttle, which was like an airplane, and it would blast off like a regular rocket ship, but when it returned to Earth, it would land like an airplane so that they could reuse it. So it had become so commonplace. I mean, I still remember this, that people just weren't even paying attention anymore. People didn't even know when there was going to be a launch. Nobody was paying attention. So NASA decided that to get people interested again, they were going to send the first citizen up into space. So they decided it was going to be a teacher, a high school teacher, and they had a competition, and a lot of people entered, and they finally decided on a teacher named Krista McCullough. You can see the name down at the bottom, and there's a little apple there for being a teacher. So in the months leading up to the launch, there's videos of her rehearsing. What was going to happen was from space, she was going to be giving lessons, and they were going to be broadcast in the schools. So this was a big deal. And so all of the schools, the morning of the launch, from elementary through at least high school, they had their TVs in their rooms, and they were all watching the launch. And unfortunately, after it took off, there was it's called an O-ring, and it caused things to explode, and the whole thing exploded. And it was just a terrible, awful thing. And I found out from my daughter that I'm not even sure if they're teaching this in school anymore, because it was so long ago. But it was the second big, really big accident that happened for NASA. So now that I've told you all that horrible stuff, let's move on. This is an early example of a patch created in a software program called Xenographics. So this is 1989. This is before Illustrator existed. And actually before Illustrator existed, they had a program called Freehand, I think. And then Adobe Illustrator took over for that. Adobe Illustrator is the software used for all of the NASA patches. So the exact software that you will be learning in this class and that you will be using is the same exact software, same exact tools that they use over at NASA for designing all these patches. So if you look at the difference between this, which was a very early software program, to these, you can see how far they've come. Sometimes the NASA designer initiates the idea for the patch. Other times the crew will bring their own ideas, often created by an outside designer or an uncle or a friend or a family member. So the initial patch design idea for this was astronaut Rich Clifford's 9-year-old son. He had drawn it with colored pencils, and this kid is now an architect. The designer works very closely with the crew to create the patch. So, and they also got lots of details about the things that are gonna, happen on the mission. I'm assuming that all of these little gadgets have something to do what was going on that mission. So this was the Columbia accident, which happened in 2003. I have no idea when you guys were born, but this may be something that was it's a little bit closer to your lifetime. So the space shuttle broke up as it was returning to Earth, killing all 7 astronauts. So it had already gone up, did a successful mission, was on its way back down. And when it was coming through, so there was a big fiery, the very, very hot area in the core, something that the spacecraft has to come through before it lands. And there was some kind of a piece that was wrong that allowed the heat to get in. And so NASA suspended the space flights for over 2 years as it investigated the cause of the Columbia disaster. And I believe it broke up over maybe North Texas, I think. So there were no flights in 2004, and in 2005, it returned to flight. And so this is 03, this is 05. The Shuttle Challenger outline was incorporated into design in the 2005 patch to commemorate it. So how long does the design process take? It depends on how many iterations there are. It could be done in 4 hours. It could be done in 40 hours. The astronaut office, there's literally something called the astronaut office, which I think is great, has placed a limit of 45 hours on the design process because of funding. They may exceed this number in certain circumstances, such as having to incorporate crew name changes. So sometimes they change who's going to go on the missions. Somebody gets sick and they've got to change them out. But they've got to pay a designer for all of the hours that they're making changes to this. So yeah, the NASA office finally said, look guys, we got to put it into this. Some patch designs could have upward of 20 iterations, 20 different patches until a final version is achieved. For simple designs, it takes much less time. So these are both patches from 2006. You can see the one on the left is very, very detailed. The one on the right is much more simple, but they're both designed very well. Lots of names that they've had to incorporate into these. Sean Collins was the lead designer at NASA. I'm not sure if he's still there, but he was the one that I listened to in the podcast, and so he described the designing of this patch. And so this is a quote: "Did a ship on it over the horizon? Did the ship coming at me? Did the ship going away? Ship sideways, and we ended up with the ship." Going away, but the names were changed. That crew changed a lot. It had a wave behind the ship, and so some of the names were too long. So I had to move the wave. I moved the wave back and forth several times. So you can see the if this was originally Smith, you can see how they would have to redesign because this was probably overlapping and things. But man, really hard to read once you stitch that up. The approval process. This is the approval process for every patch. The coordinator will approve it, and then it'll go to the astronaut office. And then it goes to their management. It goes through headquarters. It goes through about 12 approvals. Once it gets approved, the thread colors are blocked out and die cuts made, and then it is sent off for bidding for, I guess there's not just one place that does the patches, but they have to send it out because it's a government thing. They have to send it out and get approvals. So this is something that I want you to kind of understand here. So these were all of the Apollo patches. So Apollo was the name of the overall program when they first went to the moon. So Apollo 11 was the one that landed on the moon. Apollo 13 was the one that they made the movie about. So all of those were Apollo missions. So this here in the middle is the main, like all of the missions. This is, let's see, Apollo mission patches are around the circle. So the Apollo logo. So this would be considered the Apollo logo. And then each of the missions are around here. So I want you to understand that, because what you're going to be designing is for the newest missions, which are called Artemis, and there is a main Artemis logo, but then there will be individual mission patches for each of the Artemis missions. The mission patches do not include this in them. Okay, this is separate. These do not have to have, they do say Apollo, but they do not have this on the patch. So keep all that in mind when you're designing. So this is the newest mission going on, and this is all real. Artemis, well, this is kind of hokey, but it's directly from NASA. Artemis will light our way to Mars. The new Artemis identity draws bold inspiration from the Apollo program and forges its own path, showing how it will pursue lunar exploration like never before and pave the way to Mars. So if you look at this one, it's got a swoop here going from Earth over this way over to the moon. And if you look at this one, it's kind of going this way up to the moon. So with Earth blue, the rocket red, and the lunar silver for colors, every part of the identity has meaning, and this is true for all of the patches. There's books that I have that explain all the details of all the different patches and what they mean. So the A is the symbolizes an arrowhead from Artemis's quiver and represents the launch. So when you're doing your research, which you'll be doing a lot of research on this, you're going to come across the fact that Artemis is the sister goddess to Apollo, and that she's got like an arrow and all this kind of stuff. So the tip of the A up here points beyond the moon and signifies that our efforts at the moon are not the conclusion, but rather preparation for all that goes beyond. So the Artemis missions that you're going to be reading about are talking about going to the moon. But the eventual idea is that it's going to take astronauts to Mars, which is super cool. The Earth crescent, which is here, the crescent of the Earth at the bottom shows the mission's of humanity's perspective. From Earth we go. Well, I'll let you read all of that. So it also represents like the bow, okay, like the bow and arrow. This is the trajectory from Earth to the moon. And then you've got the moon. Okay. So this again, this covers like the entire programs, all of the Artemis missions, 1 through whatever we end up with. This is kind of the overall logo. Each mission will have its own patch. And this is the patch for Artemis 1. When I first started doing this project about 5 years ago, they hadn't launched any of them yet. And now they have launched one. And so they designed this logo right here. Showcases the space launch rocket carrying the Orion spacecraft, which is way up here, lifting off from the launch pad. So as you can see, there's no names on this. That's because Artemis 1 went up and orbited the moon and came back down, but it did not have any astronauts on it. It had these like dummies on it, and all kinds of equipment that would register what was going to happen inside of the spacecraft. So that's why it doesn't have any, it's got no names on it. Let's see here. So there's symbolic meaning, of course, for all of the parts here. So we've got the triangular shape, which represents the 3 main programs that comprise NASA's deep space exploration system. We've got the Orion, which is the spacecraft. We've got the SLS, which is this really powerful rocket that gets it off the ground and up into space. And we've got Exploration Ground Systems, which is, I guess, the guys on the ground that are controlling everything. And it's classic shape for a NASA mission patch dating back to the shuttle era. The orange rocket and the flames represent the firepower of the SLS, which is currently the most powerful rocket to successfully take things into space. I think Elon Musk has tried to launch something that's more powerful, but it kind of keeps exploding. So far, this is the most powerful, more successful, a lot more powerful than the ones that would launch the shuttle and the Apollo missions. the three lightning towers here. So the launch pad that they launch from is a very famous, it's called Launch Pad 39B, and it's the one that the Apollo missions would launch from. So, and they've got these three towers there. So that's what those towers right there, they're representing this launch pad. The green and the red mission trajectories. And we got the moon. Gradients. So this was from 1993, and this has, if you look down here, this actually has gradients. You can see what it looks like once it gets stitched. So the gradients cost a lot of money to print back then. And so they said no more gradients because it cost too much to create these. So let's see. It's hard to print, and it costs like 4 times as much, is what the designer said. So years ago, I don't know if this was the last year, but when you're looking through the different patches, you'll notice that some of them have gradients, but they don't allow gradients anymore. So in your design, you will not be allowed to have gradients. For years, NASA had a limit of 8 colors, solid colors, no gradients. So as you can see here, these are the 8 colors. White counts as a color because you need to think in terms of that's a string. Okay, that's a thread color, right? So white would count as a color. Black would count as a color. Those count as colors. You can see that this doesn't have any black at all because it only had 8. So any place it wanted something to be dark, it just uses this very, very dark blue for it instead. So this is what the patch looks like from that one. However, and this is new. Up until I saw the patch for Artemis 1, my students were only allowed to use 8 colors when they designed. But they have now, when I saw this patch and I started counting up the colors, I'll be gosh darned if there isn't 10 colors now. So you guys are going to be able to use 10 colors. That's 2 more than they've been able to use in the past. So I want to show you the colors here, that the way this breaks down. So we've got black. We've got gray 1, gray 2, gray 3. So keep in mind that every shade or tint of a color counts as a new color, because remember, that's another string color. So if you're using blue, but you're using a light blue and a medium blue and a dark blue, that counts as 3 colors. That doesn't count as just 1 color. Oh, there's a fourth gray. We got blue. We've got red. We've got an orange number 1 and orange number 2. You can see just a little bit there along the side. There's another orange. And we've got white, because remember, white counts as a color because it's a string. That is what the patch actually looks like, and I own this. You can buy a lot of the patches. Of course, they're not ones that really went to space, but they've got a lot of them that you can buy. And as you can imagine, you can hear from my enthusiasm, I've got a lot of the patches. This is the Orion spacecraft here. The astronauts will travel to the moon and Mars in Orion. The modern spacecraft fit for deep space exploration. It's large enough to hold a crew of 4 of them sitting there very tightly, and the necessary cargo. Orion can endure longer travel without docking and extreme temperatures. The software on board is so advanced, it computes 4,000 times faster than the Apollo spacecraft computers that got us to the moon for the first time, which completely makes sense because, back in 1960, whatever that was, computers took up entire rooms, right? So over the summer, past summer, I went to Kennedy Space Center. That's in Florida. And did not expect this, but they have a full-size replica of the Orion spacecraft. You can imagine how excited I was when I saw this. So I took a video. Let's see if this is going to play. So this is live side. You can kind of see the size of the people in the background. I had my daughter on the sides trying to keep people from walking into my video here. Really cool. Really cool. And there's me to show you that I was actually there. Okay, so I want you to pause this, or after we finish this, I want you to go onto Blackboard and I want you to watch the video called How We Are Going to the Moon. So this is kind of a cartoon video that NASA made that talks about the Artemis missions, and it gives you a lot of information. It's going to talk about the Orion spacecraft. So you need to go and you need to watch that. Consider that part of your research for this project. I also want you to go and watch also on Blackboard under lectures. NASA launches Artemis 1. So this was video of the launch of Artemis 1. They have not done Artemis 2 yet. So again, Artemis 1 was the one that went up with the Orion spacecraft for the first time and orbited the moon and then came back in the way that it splashes back down in the water, just like the Apollo capsules used to do. Artemis 2 is going to be launched sometime next year, I think. And it's not going to drop people on the moon yet. It's going to take people up in the spacecraft, and they're going to do the same thing. They're going to go up and they are going to orbit the moon, and they're going to come back down and splash down. But it's going to have famously, it's going to have a woman on it, and it's going to have a person of color. In fact, this is the first time that the commander of one of the missions is going to be a person of color. So that's pretty historic. And this mission is going to take, for the first time, a person of color and a woman to the moon. So, but some of the information about this Artemis 1 launch, as you can imagine, it was, I was very excited about it launching. The first time it was going to launch was sometime of August last year. It was going to be in the middle of the night. I was watching it. They had to scrap it for several times. They actually had 2 different delays because of faulty temperature things, hydrogen leaks. They kept saying they got hydrogen leaks on them. So they kept scrapping it and they didn't do it. So they were originally supposed to launch in August. They eventually launched it in November at like 2 a.m. So the duration was 25 days. That's how long it was up there. It traveled 1.4 million miles. I'm reading this. I don't have this memorized. Reentry speed was 24,581 miles per hour. That's Mach 32, if you want to know. It splashed down on December 11th. So it took off on November, what did this say? November 16th, and it came back on December 11th. So it's a short little video. It's interesting. It was exciting because this is the first time that they're going back to the moon. They haven't been to the moon since the 60s. They got up there, they decided everything they needed to know was there. The video, this video here is going to talk to you about why they are going to the moon. But the bottom line is they're going to the moon to prepare for when they go to Mars, because what they eventually want to do is they want to put people on the planet at Mars. And so they're going to go to the moon and they're going to do a lot of experiments and they're going to set up for people to be there for a long time. And this is all in preparation for them to be going eventually to Mars. So this is the project that you are going to have. By the 2030s, the Orion spacecraft will take astronauts to Mars. Now I think that's changed a little bit. I think they may have pushed it back to 2040. But that's true that they're headed to Mars. So your challenge is to create a patch design to honor this achievement. This patch would be worn by astronauts and crew members for the Artemis 14 mission to Mars. Do not use the Artemis logos found online. Disclosure, I'm taking liberties with the information available from NASA. When humans actually travel to Mars, it may not be Artemis 14. So what I did was, when I first started researching this about 5 years ago, they had some estimates. I kind of counted, when they were supposed to start with Artemis 1. I kind of calculated how many missions they might have by year, and I came up with Artemis 14, which I thought was a pretty good guess. So what you're going to be designing is you are going to assume that the next mission that's going up is this mission called Artemis 14. And it is the first one that's going to take people to Mars. So the goal is the big deal about this mission that you're designing for is that it's going to Mars. Not that it's going to the moon, but that it's going to Mars. So these are the specifications, and I am going to, I'll do another video where I go over the project sheet, but these are the specifications of your project. The patch design must include the following: an illustration of the Orion spacecraft. And these images are up on Blackboard. You'll be able to find a lot more when you're doing your research. So this is what it looks like. And when I talk about the Orion spacecraft, I'm talking about this part here that holds the astronauts. Okay. You can show it this way, or you can show it this way. This part right up here is also, this is the Artemis capsule right here. This has these little flipper things that help move it around. Because what happens is the big rocket ship gets it off of Earth, and at some point that rocket ship drops off, and what's left is this right here, and this floats to it's called the Gateway. They're going to dock there, and then they're going to take something that goes down to Earth. Don't worry about all that. Just know that you have to have either this version or this version on your patch. Now, it doesn't have to be from this angle. When you get online, you're going to find lots of different angles, but we have to be able to see this. Don't worry about showing the rocket. By the time we're going to Mars, the idea of this SLS rocket is going to be old news. It's not going to be interesting anymore. So we're going to make sure that you can show this. You have to, somewhere it has to say Artemis XIV on it. Don't write for the word 14, okay? It's got to be XIV. You need to have the last names of 4 to 6 astronauts. These can be fake. Use whatever names you want. You have the luxury of making the names as short or long as you want to. Whatever works with your design. You can use your name. You can use your friends' names. You can use whatever last names you want. Only last names. Don't put first names and last names, just last names. No gradients in it. You're limited to 10 colors. Remember that black counts as color, white counts as a color, and every different shade or tint counts as a different color. You've got to have only 10. With that, you can include any other illustrations or text that you want to include that relate to the mission. If you only have one planet on there, it should be Mars, because that's the big deal now. It's not Earth and it's not the moon. You may decide that you want both Earth and Mars in there. You may decide you want both Earth, Mars, and the moon in there, okay? But if you've got planets on there, at least one of them should be Mars, because that's the big deal.